Hey, what's up, y'all? Thanks so much for joining me for another processing tutorial. This one, again, on object-oriented programming. I think we're going to cover a couple new things in today's video. We're going to look at the switch function and the scale function, as well as build on all the skills we learned in the last OOP video to create something that's a little bit more complex and interesting than our simple ripple simulation from the last video. I designed this sketch to serve as sort of like a template that y'all can customize and extend and use in your own works. So to get started, let's take a look first at what's going on, and then we'll kind of break down what the class is going to need, and break down this sketch into more manageable, bite-sized pieces that we can kind of execute one at a time here. So taking a look here at the sketch that's running behind me, what we're doing, or what I'm doing here, is I've written a class called shrinking shape, right? And so each one of these shapes that you see is an object, and all it's doing really is spawning at some random position and rotation, and then shrinking over its lifespan. And when it reaches 0, it simply gets removed from the sketch. And as the sketch is running, there's a control structure in here that I've written that we'll go over as well, that just spawns a new shape in each of the quadrants, one after the other on the screen, just to keep kind of providing full coverage of the screen. So to get started with coding, let's actually move here to pen and paper and kind of take a look at what we need to accomplish and how we're going to go about it. So the shrinking shape class, like I mentioned, right? Bunch of shapes that are spawning on screen, and they're rotating and shrinking. Each one of these shapes, we need to actually, each one of these objects, we actually need to be able to pass in a P shape. So we're going to make sure we can do that with our class. The class will need to generate an X and Y position when you spawn one. It will need to have an initial rotation and direction, so whether or not it's going to spin right or left. We'll need to generate a lifespan, and we'll need to select a color from like a range, a gradient range. I'm using that lerp color function, right? So I think what we're going to do today is we're going to first just look at how to create the custom shape that I'm using in this sketch. Y'all, of course, can use any shape that you want. You can import an SVG. When you learn about images, you could import an image instead of an actual shape. So there's a lot you can do with this template, but we'll look at how to make this little plus sign that I'm using in the sketch, the example sketch. First thing we'll do, then we'll actually look at how we're going to write the class. And once we've got the class more or less kind of finished up, we'll go ahead and add in the control structure, the code that's going to actually, dictate when we spawn a new one, how many are we allowed to have in our array list at one time, when should we take them off the list, and all that kind of thing, right? So let's get started thinking about this little custom shape here, right? So in my mind, I'm kind of thinking, I want the shape itself to be, around 2/3 of the width of my display window, right? So I've kind of drawn a 6x9 little display window here, and I've drawn my plus sign taking up 2/3 of the width of that display window, right? So if I think about, how I'm going to draw this custom shape actually around the origin, right, rather than actually on the screen, if I put the origin right in the center of my shape, right, because it's a 6x9 grid here, and this is taking up 2/3 of the width, each of these little squares represents like 1/9, right, of the total width of the screen, right? So if I'm thinking about all the vertices that I'm going to need to put into a P shape to get this cross or this plus sign, or when it's rotated it looks like a little X, right? I can think in terms of like ninths of the screen, right? So my first X position, let's say I start with the vertice, the vertex right up on the top left side of this plus sign, right? So if my origin is here, I will go back 1/9, and I will go up 3/9 or 1/3. So my first vertex, is going to be negative 1/9 of the width and negative 1/3 or 3/9, right? So negative 1/9, negative 1/3. This vertex is going to be positive, right? X position positive 1/9 and Y position negative 1/9. So then I will have 1/9, negative 1/3 for the y position, right? This vertex here is going to be positive x 1/9, negative 1/9. This vertex here is going to be positive 1/3, negative 1/9. This vertex here is going to be positive 1/3, positive 1/9. This vertex here is going to be positive 1/9, positive 1/9. This vertex here is going to be positive 1/9 for the x and positive 1/3 for the height. So 1/9, 1/3. And then this one's going to be negative 1/9, positive 1/3. This will be, again, negative 1/9, positive 1/9. This one over here is going to be negative 1/3 for the x value, positive 1/9 for the y value. And then this one here is going to be negative 1/3 for the x value, negative 1/9. And then this last one here is going to be negative 1/9, negative 1/9. Okay, so this is the list of vertices that we're going to need to generate this custom shape here. So let's go ahead and move back to a new processing sketch here and put this into our code. Okay, so all the usual setup and draw loops here. And I'm going to make a p-shape called plus. And I know actually that this is going to be a lot of code here to generate this shape. So I'm going to just already go ahead and make a function so that my code will look a little neater. And I'm going to say, we're going to say create plus. Right, and then here in setup, let's make our size 640 by 480, and let's run this function, create plus here, right? So that way it'll look a little neater in setup, and we can put all of our code here. So we can say plus equals create shape plus dot begin shape plus dot end shape, and I believe we're going to want to close our shape, so we can say close here, and then we're going to need to fill in a bunch of vertices. So let's say plus dot vertex, open close parentheses, and I'm going to put this into my clipboard, Command C, so that I can come back and fill a bunch of these in. Okay, so let's go through our list of vertices from before. So that first one is going to be negative 1/9 of the width, so I can say negative width divided by 9, and then negative width, negative 1/3 of the width, or negative width divided by 3. And then I'm going to make another vertex that is 1/9 of the width, so width divided by 9, and negative width divided by 3. Another vertex. This one is going to be width divided by 9 and negative width divided by 9. Next vertex here is going to be width divided by 3 and negative width divided by 9. All right, so I've done 1, 2, 3, 4. The fifth one is 1/3, 1/9. The next one here is 1/9, 1/9. The next one after that is 1/9, 1/3. The one after that is negative 1/9, 1/3. The one after that will be negative 1/9, 1/9. The one after that is going to be, oh, negative 1/9, 1/3, negative 1/9, positive 1/9, sorry. The one after that one is negative 1/3, 1/9. And then the one after that is negative 1/3, negative 1/9. And the final point, the final vertex in this shape is negative 1/9, negative 1/9. Okay, so we made a P-shape. We described all the points, the vertices that we're going to need to create this point, this shape. Let's just go ahead and make sure that everything looks okay. So let's just say background 0, and we will say shape plus, and actually just to check and make sure, let's say translate width divided by 2, height divided by 2. Okay, and run the sketch and see what we get. Okay, so this is exactly what I wanted. This shape is looking nice and tidy. Okay, great. So we have accomplished task number 1. We've made our custom shape. Next, let's see how we're going to wrap this up inside of an actual class. So, like we did with our previous sketch, we're going to make a new tab, and we'll name this one shrinking shape. And we'll make a class and name it shrinking shape, like so. Okay, and so the first thing we want to do is actually be able to pass in a shape. So we're going to need to have a p-shape variable. We'll call it shape. And then in our constructor, we'll want to pass in a p-shape, and we can call it s. And then we will need at least a couple of methods. We already know we're going to need an update and a draw method. So let's make those. And, oh, not draw, sorry, display. Draw is reserved for this function here, of course. Okay, let's also just go ahead, and we know that we're going to use an array list, right, to kind of display all of our shapes here. So let's go ahead and make this array list, and we will add one instance of our very simple object here to it, and use that to just check that we're able to pass the shape in. So what I want to do though is make an array list, and we're going to call this shapes, right? I'm also going to tell it that it is going to be holding objects of type shrinking shape. And we're going to set this equal to a new array list, shrinking shape, like so. Okay, and then here in draw, of course, we will say for int I is equal to 0, I is less than shapes.size, I plus plus. And we're going to say shrinking shape ss maybe equals shapes dot get I, and then we will run. For now, we just need the display method to get run here, right? Let's also after we've created this plus shape, right, let's add just one object to our array list in setup here. So we'll say shapes.add new shrinking shape, right? And it needs, our constructor here is asking for a p shape, so we'll throw in our plus, right? Like so. And then it should display. Okay, so there's nothing here in the display. So it's not actually doing anything. We'll get to that in a minute. Let's make sure we're taking in the shape. So shape, right, the variable for our class, we're going to set that equal to this shape that we're passing in. And in display, let's just go ahead and say push matrix, pop matrix, translate. We're just going to mimic this picture that we have here for now. So we'll say width divided by 2, height divided by 2, center of our screen. And then we'll say shape, shape. And I think that should, let's see what happens. I think that should actually get us back to the same picture, but now, yes, using this object, right? So now we're using our class. We've added one instance of this object to the array list, and we are iterating through this array list and displaying all of the shapes that are inside of it. Okay, so we've got this, we're able to pass in a shape, right? So we can check this off the list, right? And every time I add one to the list, I don't actually want it to be in the same place, and I don't really want to have to pass in the coordinates that it's going to be generated at. If you wanted that to be, if you wanted that to be your control structure, that would be fine, and you could pass in a couple of arguments here in your constructor for that. But for our purposes, we're just going to use a couple random functions here to generate an x and a y position. Okay, so what we can do is in our constructor, let's give ourselves a p vector called position, and then here in the constructor we can say position equals new p vector random between 0 and width, random between 0 and height, and of course I need another parentheses there, and then instead of translating to these hard-coded values, we'll say position.x, position.y. Right? If we run the sketch again, it should show up in a different spot. It shouldn't just be in the middle. Okay, so that is offset from the middle. Let's run it again and see what happens. All right, so we can see this is going in a bunch of different places. All right, and so we are now also generating an XY position. Let's skip this step for now, and let's generate a lifespan and do all that code so that we can actually make this shape change over time here. So let's go back here, and we'll need our 3 variables here to take care of that. So we need birth, we need age and lifespan. And then here in the constructor, we will say birth equals millis, lifespan. We want that to be between, I think it was 20 and 30 seconds in the example code. And of course, these are values that you can tweak to suit your own needs. And then here in update, we will say age equals millis minus birth. And what we'll do is we'll say if age is less than lifespan, then I would like for something to change, right? So let's start thinking about the, here's the new function, scale function, right? So this is similar to our translate and rotate functions in the sense that it's going to act on the entire coordinate grid. And so in terms of like order of operations, you generally are going to want to do translate first, rotate second, and then scale last. Because we kind of looked at some of this examples in previous videos where if you change the actual characteristics of your coordinate grid, that can yield some unexpected results. So just remember, usually you're going to translate, rotate, and then scale in that order. and you're going to want to kind of quarantine your scale function inside of your push and pop matrices, right? So let's also make a floating point variable for ourselves to store the actual scale amount, right? And we'll say float s. And then here in the update function, we will say s equals map age, which goes between 0 and lifespan. And we are going to say, I want this to start at 2 and go to 0, right? So it'll start its life twice as big as its actual size, and over its lifespan will shrink to 0. Okay, and then here after our translate function, we will use the scale function and we'll scale it to s, right, which is what we're mapping here. Okay, so let's see what this looks like. Well, I also, of course, need to say update here in this part of the code. All right, so you can see it is shrinking, 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 shrinking. Until you can't see it anymore. Okay, excellent, right? And at this point, we actually want to take it off of our array list. So let's make another for loop here. And we'll say all the same things about grabbing the shape in the list at that point. But what we're going to do now is we're going to say if ss.age is greater than lifespan, right? If it's older than it's supposed to have lived. Then we will say shapes.remove I. Okay, and that'll take the shape off the list once it has shrunk away. Let's take a look again at our list of tasks here. So we have passed in a shape, we've generated the XY position, we've generated the lifespan, right? And we are updating, we're shrinking it as it goes on. So we need to also initialize a rotation amount and figure out a way to decide whether or not it's going to spin clockwise or counterclockwise. So let's take care of that. We'll go back here and we'll say float. We can actually just do this in here. We're going to need, let's see, angle start, right? So a starting rotation, an angle end, the end rotation that we're going to be in, and then we'll use a variable to just actually store the current rotation. Okay, and so here in our constructor, we can simply say angle start equals some amount between 0 and 2 pi, right, a full rotation. And then recall the coin toss video, right? So from before, what we're going to do is set up a quick little coin toss. We are going to say flip a coin. So we'll say random, right, int random 2, right? And that's going to give us a random number between 0 and 1. And we'll say if this coin toss is equal to heads, let's say heads is 1, right? Then I want you to set angle end equal to angle start minus, or actually let's do plus, right? So if we flip the coin and it lands heads, it's equal to 1, let's spin clockwise, right? So then we'll say plus some random amount between, let's say, pi divided by 7 and quarter pi, right? So we're going to generate a random amount of rotation between 1/7 of our unit circle and 1/4 of the circle, right? So we don't want to spin too much, but we want it to spin a little bit, right? And again, heads, we're going to add that to our initial angle, so it will spin clockwise. And tails, right? So if it's not equal to 1, our little coin toss here, right? Otherwise, we want angle n to be equal to the same thing, but instead of adding it to our initial angle, we're going to subtract it from the initial angle. So that way it'll spin counterclockwise, right? And then here in the, and we'll just set angle equal to angle start, right? So this variable here that's actually just storing the current angle, right? Or maybe, maybe this would be better named current angle. Maybe that's going to be a little more clear, right? So I can say current angle is equal to, we'll initialize it at the starting angle, right? And then here after my translate function, I can say rotate to the current angle, right? So let's run that and see what we get. Okay, so you can see it didn't start just totally upright, and it seems to be shrinking. And rotating a little bit. Okay, great. So let's also, okay, so now we need to actually select a color from a color gradient, right? So let's come back up here and we'll say color C, right? And actually what I'm gonna do is I think, every time I make one of these objects, I don't wanna have to redefine a color. So I'm gonna pass in a couple color variables. So we'll say color C0, color C1. And that will allow us to pass in color values, right? Or basically the range of the gradient that we're going to want to make the shape colored as. And then in here, right, we can say, in our constructor, we can say C equals lerp color between C0 and C1, some amount between 0 and 1, right? So this will choose a value between 0 and 1 for us, randomly selected, right? And then up here, I can say shape dot set stroke false, right? Because I want no stroke, and then I'll say shape dot set fill to the color. So when we have made one, now you can see this is returning an error because the constructor with this form, only one argument with a P shape in it, right, is no longer valid because I added 2 more arguments in my constructor here. So let's make a couple color variables here. We'll say color C0, C1. Here in setup, we're going to say C0 equals, let's grab a couple. I think, in the sketch I had a couple of blues, but let's do something that's more like purple and red, right? Or purple and pink. So let's say I want my first color to be kind of this nice like pink. So I'll say C0 equals color 254, 0, 255. And color 1, let's go to something, I guess, like a little bit more reddish, right? So this way and maybe a little brighter. So we might go this way. Yeah, I think I like this, right? So we'll say then color 1 equals color 255, 134, 215. 255, 134, 215. Okay. And then we can come in here and we can say C0, C1. And so now when we add a shape, it should select a color for us. Let's see how we did. Make sure that works. Okay, so this is starting to look better. Oh, you know what? I just realized also we're not actually updating the rotation. So my eyes were playing tricks on me earlier. So I need to actually say current angle here in my update function, right? Current angle equals map age from 0 to lifespan between start angle start and angle end. Okay, and then check on that. Okay, now we're actually seeing the shapes rotate. Excellent. Okay, so let's double check our list now. I think we're pretty close to finishing number 2 here. We've got the rotation working, and we've got our color working. So I'm going to just go ahead and check off this task here, writing the class. Now let's start to think about the code that we're going to use to kind of control how this sketch operates. So let's go back here, and instead of only generating, or only adding one shape to the list just during setup, we need some way of adding more shapes to this list as time goes on. So let's make a little timer variable, right? And we are going to set it equal to 0 here in our setup loop, and then in draw, we are going to add to it, right? And so we'll also need like a limit, right? So we'll say time limit, right? Let's say time limit equals some value between 20 milliseconds and 55 milliseconds, I think is what I had done for the example, and that ended up looking pretty good. Okay, so that's going to be our initial time limit here, right? So as long as if timer is less than time limit, right, we can go ahead and increment it, right? And if it's not, right, if timer is somehow greater than the time limit, right, it's exceeded the time limit, what we're going to do is we are going to, once the timer goes off, let's add a new shape. We're also going to, we want to give this a little bit more variety just in when the shapes respond and how they look, right? And we'll say we're going to make the time limit also change, right? And then we'll reset the timer to 0. The other thing that I want to do is also kind of set like a maximum number of shapes, because again, each one of these is getting generated and spawned underneath of the previous shape, right? And so we want to actually be able to see all of the shapes that are on the list, and that's kind of the point, right? That we want the ones that are shrinking to reveal the ones that are underneath. But the point of me bringing all this up is that if we don't have some kind of limit on the number of, the maximum size of this array list, it's just going to keep adding shapes every 20 to 55 milliseconds, and we'll end up pretty quickly with a really slow, kind of lagging sketch, just because there will be so many shapes that are being rendered but not actually seeing. So let's make another, we'll say max shapes, right? And I think in my example, let me see, what did I set that to? 35 was yielding pretty good results. So here in the setup loop, we'll say max shapes equals 35, right? And then we'll say here, as long as if shapes dot size is less than our limit, it's less than 35, right? Go ahead and add a new one. Okay, so that should kind of keep things clean as far as the size of our array list. So maybe at this point, there's a few other things we'll need to do, but let's turn this on and see how it looks. Okay. And this also, okay, so this is working, right? It's also revealing another issue. So I do want to actually see the first thing that we've added to the list, right? But the way that this is working is right now we're iterating through it from 0 to the end of the list. And as you add things to this array list, the first thing that you add gets actually pushed to the bottom, and then the next thing that you add gets, so they're getting, the first thing on the list is now the last thing that you added, right? So for us to do this, we actually need to set this int I equals to shapes dot size, and then check whether or not it is greater than 0, and then we need to minus minus like that. And actually, we're going to want to set this equal to this minus 1. Okay. Okay, and now you can see the first thing that appears is going to be drawn first. So now the last thing in the list is getting drawn first. So we're iterating through this loop backwards instead of forwards. Okay, and now this is kind of looking a little bit more like what we had in the beginning. So you can see the coverage is a little bit spotty, and that's, it has to do with a few reasons. So there's a few things that we can do to kind of help this out. And so first, let's look at actually how we're going to use the switch function to help us manage that. So let's manage our coverage. Let's go back to pen and paper here for a minute and look at the switch function, right? So switch has some kind of number here, right? And it acts a lot like a bunch of different if statements, right? So this is one of those things that you can use instead of a bunch of different if statements all in a row, right? So you can say switch number, and then you'll have a case, right, with that number, and then to exit that case, you'll say break like this, right? So this is kind of just like having a bunch of if statements in the same function. Instead of writing a bunch of different if statements, you can just have one switch function, right? And so what we're going to do now is also in our control structure code have like a variable that's keeping track of what quadrant we drew the last shape to and updating that every time we draw a new shape. And then in our class, we're going to put one of these switch functions, right? We're going to pass in the quadrant that we're intending to draw the shape to, and this switch function will then control how that's going to work. So let's start by working on the control structure code really quick here. So let's come up here and say int quadrant, right? What quadrant do we want to be in? And we can initialize this just at 0. We know it's going to be 0, right? And in our shrinking shape, let's add a integer that's named quadrant, right? And we'll come back to that in a minute, but we know that we're going to need to pass in the quadrant, right, that we're in. And the first one is going to be 0. And then what we'll do is we'll say quadrant plus plus, because now we've added one in 0, and we want to go to the first quadrant, the next one, right? And then here, yes, we also need to say quadrant, right? And we know there's 4 quadrants, right? So we'll say if quadrant is less than 4, quadrant plus plus, right? So then that should be 0, 1, 2, and 3. And then we'll say if quadrant is greater than or equal to 4, reset quadrant, right? So now every time we create a new shape, right, we're going to also update this quadrant variable so that it changes each time, right? And so now this, depending on what, where we are in our code, how many shapes we've made, will either be 0, 1, 2, or 3, right? And so I'm trying to actually change the position that we're spawning our shapes at based on what quadrant we're in. So that's where I'm going to use this switch function. So I can come in here and I can say switch, and then quadrant, right? This variable has been passed in. It'll either be 0, 1, 2, or 3, right? And then I'm going to have a bunch of different cases. So I'll say case 0, break, case 1, colon, break, semicolon, case 2, colon, break, semicolon, case 3, semicolon, colon, and then break, semicolon, right? And then Command T. This is the actual syntax, or formatting, rather, that is generally used, and I'm just too lazy to actually put the line breaks and tabs in. Just use Command T for that. Okay, so what we can do is then we'll take this code out of the constructor here, and let's start by just looking at case 0, right? So let's imagine that quadrant 0, let's take a little grid here and divide it up, right? So this is 0, this is 1, this is 2, and this is 3, right? So the first quadrant, we want to be somewhere between 0 and width divided by 2, 0 and height divided by 2. So in our random functions, we can say width divided by 2, height divided by 2, right? Oops, I need to actually show you all what I'm doing in the code. Okay, so I just said width divided by 2, height divided by 2, right? Now, in case 1, we'll say the same thing. Position is equal to a new p-vector, but we want it to be between width divided by 2 and width, right? And we want it to be, again, between 0 and height. Now, in the case of our second quadrant, we'll want this to be between 0 and width for our x, and then we want it to be between height divided by 2 and height. And actually, this one here needs to be height divided by 2. Sorry about that. And then the last case, right, will be between width divided by 2 and width, and height divided by 2 and height. So if you want to see that again here, right, we're going for quadrant 0, some value between 0 and width divided by 2, 0 and height divided by 2, some value between width divided by 2 and width, and 0 and height divided by 2. For quadrant 2, it's some x value between 0 and width divided by 2, some y value between height divided by 2 and height, and then for quadrant 3, it's some x value between width divided by 2 and width, and height divided by 2 and height, right? So that's how I got that code here, right? So now, as the sketch is going, it's going to spawn one in each quadrant, right? So hopefully that should start to get us a little bit better coverage, right? Okay, so let's run the sketch and see what we're getting. And so you can kind of see, hopefully, that these are being randomized in the different quadrants. And the coverage is, in fact, a little bit better. And as time goes on, right, we seem to get a little bit better coverage. Something else that we can do is actually just have the shapes not shrink immediately, but wait a little bit until they start shrinking. I think that's also going to help with the coverage so that we don't see through to the background. So let me add some code in really quick that's going to do that for us. So what we can do is go back to our update function, and what we'll say is, as long as age is less than or equal to lifespan, do these things. And so what we want to do is we want to say if the age is less, let's see, so we want to wait. So age should be greater than, right? Let's say lifespan divided by, how about 4? So a quarter of its life. It's not going to start shrinking until it's at least a quarter of its lifespan. Actually, yeah, let's start with that and see if that works for us, right? So then the scale can be between 2 and 0. And that means we'll also need to actually just initialize scale here in our constructor. So let me come up here and I'll say s equals 2. That way it will still work here, even though this is not going to kick in until after it gets a little bit older. Okay, and let's run this. Hello? Ah, okay, so I'm running into an issue here. With duplicate naming things. Okay, so let's say scale. And then here we're going to say scale. Okay. And you can see these are jumping to a different size because I also did not change this parameter in our map value or in our map function. Need to do that. Okay, so now that's more, it's a lot smoother, and you can see the coverage is a lot better now that they're waiting a little bit longer. Okay, so this is behaving okay. I think, the other thing that I did in the example to just kind of fix the coverage without having to just increase the maximum number of shapes. So that's the other thing, right? Right now I'm limiting the number of shapes that I can add to my array list. And depending on how powerful your computer is, you could, say 1,000 or 10,000 or whatever, right? So you'll have to play around with this variable to kind of see like what your machine can handle. Of course, if there were more shapes, there would just be more of them on the list, and you just wouldn't have any of these gaps if you had enough of the shapes, right? I think because I am, like recording a video while doing this, and also not running this sketch on like the beefiest computer in the world. I think this is like a 2015 MacBook, right? I'm limiting the number of shapes. So the other thing I can do is I can just say, instead of coloring the background black, let's just make this the color, of one of the colors of the actual gradient itself, right? And so now you have sort of like a full coverage kind of texture here, morphing gradient texture, without actually having to mess around with too many more of the shapes. Yeah, okay, and this is kind of looking pretty convincing here. I'm gonna watch it for another second or two. So it's not bad. Yeah, all right. So I think this is kind of what I had, in the example code. And like I was saying, I designed this for it to be a template. So I really encourage y'all to, make your own shape or import your own SVG, or go and watch the video on images. And instead of using a shape in this class, and displaying a shape, display an image here instead, right? So you can use this same kind of texture, morphing, evolving texture with a bunch of different shapes or images. And you can really get creative with this. You can make them different colors. You can make them move around. I'm not actually moving the position of these. I'm just changing the rotation after it's been spawned in a fixed position, right? So you can really get creative and kind of do whatever you want with this template. But hopefully this inspires you to kind of use some more classes and some more object-oriented programming in your pieces going forward. Okay, I'll see you in the next video.